In this video, I want us to talk about factors that affect the lattice energy. Now, lattice energy is simply the electrostatic force of attraction that we have when oppositely charged ions form a crystal, that is an ionic compound. Okay, now that electrostatic force is equivalent to the lattice energy. So lattice energy is simply expressed as K, Q1, and then Q2 divided by R squared. So you come across this in your physics lesson. So the Q we have there, Q1 and Q2, this corresponds to the charge of the ions that you have in the ionic compound, and then the R stands for the distance between the centers. So distance between centers. Okay, so with this formula we can work out what the lattice energy is for ionic compound. But then let's look at the factors. So that simply means that the factors here include 1, the size, and 2, the charge. Okay, the size and the charge. All right, so what do we have to take note of when we are talking about the size? Now look at this. So for a given anion, the lattice energy gets less exothermic as the size of the cation increases. So that means that the size of the cation affects the lattice energy that is involved. Okay, so let's look at lithium fluoride. If we take lithium fluoride, let's also take sodium fluoride. So we are looking at the fluorides of group 1 metals, potassium fluoride, and then we also have rubidium fluoride. Now in this case, since we have the same anion, the anion there is fluoride, and then we have different metal. However, these metals all belong to the same group, and as you go down group 1, the size of the metal increases. Okay, so what is going to account for the difference in the lattice energy? It is the size of the cation. So what happens is that lithium fluoride is going to have a higher lattice energy compared to sodium, which will have a higher lattice energy compared to potassium, and then compared to rubidium fluoride. So in this case, the size of the anion determines the variation in the lattice energy. Okay, all right, now what about the anion? So for a given cation, the lattice energy gets less exothermic as the size of the anion increases. So just like the cations, the same thing applies to the anions. As the size of the anion is increasing, you expect that the lattice energy should also be decreasing. Is that okay? All right, so that means that if you take let's say the fluorides of any of the group 1 metals, so let's take lithium, and then we take the halides of lithium. So if you take lithium fluoride, and then you take lithium chloride and lithium bromide and lithium iodide, so what is going to be the variation in the lattice energy? Now notice this time we have the same size of cation with the same charge. However, the anions, we have fluoride, chloride, bromide, and iodide. And as you go down the group 7, the size of the anion is increasing. So we'll say that as the size of the anion is increasing, the lattice energy is also decreasing. That means it's becoming less exothermic. Is that okay? All right. So we can say that the charge, now talking about the charge density decreases as radius increases, because the same charge is going to be spread over a wider area. Is that okay? So I would like us to compare the following and see which one will have a higher lattice energy. So if you take lithium fluoride, so lithium fluoride and magnesium oxide, which one is going to have a higher lattice energy? So we are looking at size and charge. Now let's give priority to the charge. Now in the case of lithium here, lithium is +1. Okay, lithium is +1 and the fluoride is -1. Now magnesium over here is +2 and then the oxygen is -2. So if we go back to the formula, here, you'll notice that the charge, which is the numerator, so as the charges are increasing, coincidentally the lattice energy is also going to be increasing. So between lithium fluoride and magnesium oxide, we can clearly tell that the product of the charges, we are going to have magnesium oxide to have a higher product compared to lithium fluoride. So we'll say that magnesium oxide is more exothermic compared to lithium fluoride. Is that okay? Now, what about lithium fluoride versus potassium bromide? Okay, so for lithium has a charge of +1, fluoride also -1, potassium +1, fluoride, bromide -1. Okay, so among these two, what is going to be the distinguishing factor there? Lithium fluoride and potassium bromide. Now lithium has a smaller size compared to potassium. Fluoride also has a smaller size compared to potassium bromide, compared to that of bromine. So we can clearly see that among the two, lithium fluoride will have a higher lattice energy compared to potassium bromide. This time the size of the cation or the anion is distinguishing their lattice energy. Now let's look at calcium oxide and sodium chloride. Now calcium oxide, for calcium we have a charge of +2 and oxygen is -2. Sodium is +1, chlorine is -1. Okay, now straight away we can look at the charge differences. Calcium is +2, oxygen -2. So that means that if you look at the product between the two, looking at the formula, it is clear that calcium oxide will have a higher lattice energy compared to sodium chloride. So these are the factors that affect lattice energy. Keep checking our channel for more videos. Thank you.